Okay, so once again, we are back with 3.4. Okay, and if you remember, this section is about the application you have on, or rather the application on the problems you have seen in the previous section. That means previously you've just seen the problem. Now you'll see what it actually means in real lives. So we have already discussed one problem from it, if you remember, or if you have already seen the video. Today, let's try two more problems. So I'll write 2 here. That's our example 2. I've already sent you this file, this PDF file for 3.4. So what you can do, you can open this file if you want to visualize things, more or better, I should say, or if you want to see the question when you are actually observing what I'm doing on the other screen. Okay, you can open that file if you want. Okay, so the question is, a farmer has a 2,500 yards of fence to enclose a rectangular field. What are the dimensions of the rectangle that encloses the most area? Okay, so first of all, how does a rectangle look like? That's more important, right? So first of all, a rectangle looks like this when, or rather where, we say this is the length and this is the width. You don't need to denote this by L and W. You can use whichever notation you want. You can use X and Y, so you can use A and B. It doesn't matter as long as you use it right. Okay, so a rectangle is of this shape, and from this we want to find the values of L and W. The question was, if you remember, or if you have it in front of you right now, what are the dimensions of the rectangle? That means we are actually looking for these two values. Okay, now the first and most important question of this problem is, what's the thing from this rectangle we should work on? Is it the area? Is it the perimeter? Is it the diagonal length? What's that? What's the deal? How can we deal with this? If you have the question in front of you, you can eyeball the question again and try to visualize. Don't see the solution first. You have the solution there, but don't see that. Try to understand what the question is looking for and try to relate that, try to synchronize that with your common concept of a rectangle. The informations you have, the formulas you know. Anyone? You can try, as I said, even if you're wrong. No problems with that. Length times width. Okay, so what do you mean by length times width? I mean, okay, so do you have the file? What you can do, you can actually open that. That would be better. You can actually see the question then. It will take longer time if I just say the question again and again. If you can open that and see that in a different window, you can always switch your windows. So there is no problem in doing that. But my question is, how do you define length times width? For a rectangle, what does that mean? What does length times width means for a rectangle? Because you need to have a relation. It gives the area. Okay, yeah, that's right. That gives you the area. And why do you think we should work on the area? Which part of the question made you think like that? Meanwhile, if anyone else has a different opinion, you can share that as well. Okay. So again, we know the area of this rectangle is 2,500 yards. Okay, we know that. But if you look at the question, it says we need to fence that rectangular field or whatever it is to for enclosing that. Now here you actually need to use your common sense rather than mathematics. So when you're trying to fence a field or anything where you're trying to enclose the entire area with that fence, okay? So what that means is we are actually looking for the perimeter, okay? Now, where is the perimeter? Oh, I think I misread the question. It says the farmer has 2,500 yards of fence. Okay, sorry. So he has already fenced it. That's not the area, by the way. That's actually the perimeter. He has already, yeah, he has 2,500 yards fence. So he has actually fenced it already. So let me fence it first. So if you are trying to enclose a field or anything like that, you actually use fence in the perimeters only, not the entire area. Like this, I'm using red colors for it. Okay, so that's the fence in red color. You can see that's only taking all the length. What I mean by all the length is all the sides, precisely, only all the sides. Okay, it's not taking the entire area. So now the question could be, what's the formula of the perimeter of a rectangle? So if we have a length of L and width of W, the perimeter is 2L plus 2W. Okay, you need to remember this. I don't think this will be given in your exam, but just in case if you don't remember what's the formula of the perimeter rather, generally the perimeter is the sum of all the sides. So as you can see in this rectangle, I have two W's. This one is W, this one is W, this one is L, and this one is L. So if I want to add all this, all I'll get is two of these L's here and here, and two of these W's. So that's how 2L plus 2W comes. Okay, just in case if you don't remember, you can use this for any shape. Your perimeter is actually the sum of all the sides, and we know we have a fence of 2,500 yards, so this equals to this. Okay, excuse me. Okay, now the question says, what are the dimensions of the rectangle that encloses the most area? So as Pearson said, we'll actually work on the area. We want to work with the area. So we know these values. Next up, we want to use the formula of the area to find the values of L and W. And of course, the area of this rectangle is, as Pearson said, length times width. That's the area. Let me write A for it. A for area. That's your area for this particular rectangle. Okay. But as we are trying to maximize it, if you remember, previously we have worked on the functions which is only of one variable. It was either for X. We have also worked on a problem which has a variable P, but it didn't have more than one variable, whereas on this occasion we have two. So somehow or other, we want to replace or substitute rather one of the variables by the value of the other. So for that, we can use this information. Let's see how we can do that. let's say I want to replace the W here. So if I want to do that, I want to solve this equation for W. So 2W will be 2500 minus 2L. I'm just changing sides for this 2L. And if I divide both sides by 2, then we'll have this, right? I'm just dividing both sides by 2. So this will be 1250 minus L, right? So this is the value for your W, okay? Now we'll replace it in our formula for the area. So L will stand as it was, and we'll replace the value of W, which is 1250 minus L. If we simplify it further, you can see 1250L minus L squared. Now it's only a single variable function of L, and also it's a quadratic function, which we wanted because we are trying to use our concept for the quadratic function on this chapter, right? So this is indeed a quadratic function, okay? And now from this, we want to find the value of L. Now, how can we do that? Any guesses? Because we have worked on problems like this. So your intuition should give you some hints. Anyone? Okay, no one so far. Without wasting any more time, let's move on. So first of all, as we are trying to maximize, our intuition should say that we'll have a shape like this, right? Because on that occasion, this will be the maximum point, absolute maximum, right? So let us check what our concept says, what it actually does concept-wise. So in terms of L, my function is now negative L square plus 1250L. As you can see, the value of A, if you compare it with x squared plus bx plus c, if you compare it with the original format, you can see the value of A is actually -1. And we know if A is less than 0, then we have a concave down. And that way we know that we have a maximum there, right? So definitely, if we can find this point, we can actually calculate the value of L. And from the L, we can also calculate W as well. And that's what we want. Now, what does this point call? How can we define this point? Do you remember? How do we define this point? Vertex, exactly, yeah, thank you. If you remember from the last one, if you have already seen that, we call this point, or we define this point as the vertex. And fortunately, we know the definition of the formula for calculating vertex, which is, if you don't remember, let me write it for you, B over 2A. Of course, A and B will come from this. Now, for this particular problem, let us plug in the values. Can you see the value of B? Can you see the value B? Oh, some guys are still trying to join. Let me admit them to the meeting first. Okay. Okay, so the value, as you can see, of the value for B is 1250. So you can plug in 1250 here. The value of A, as I said, is -1. So 2 times -1, this negative and negative will get cancelled. So if we divide 1250, not L, Ryan, L is actually the variable in terms of which in terms of what you are trying to find the value, like x on this occasion. So you are actually looking for the coefficient of L instead. Yeah, so it will be only 1250, not 1250L. Yeah, that's, I think I should mention that as well, because this looks like a common mistake. This could happen, you know. You can always get carried away because often you are seeing everything in terms of x, in terms of x, and suddenly you have L. So you might think the entire thing is your B. That's not the case. As your main function is in terms of L, so that means you are actually looking for the coefficient of that. Okay. You don't need to be demoralized if you have done this before, because that's a common mistake. You can always come back from it. Okay, so if we divide 1250 by 2, we'll get a 625. So that's one coordinate of the vertex. We know the vertex is of this format. The first one is from the x-axis. The second one is from the y-axis. So we have already got this value of x, or in other words, for our problem, yeah, that's the x, yeah. So in other words, for our problem, this is L. Oops, sorry. This is L and this is W. Okay. So now, as we have got the value of L, how can we get the value of W? Okay. So what you can do, we already know the substituted value of W. We can plug in L here to get W, or we can always plug it back. Oh, I think, no, sorry. So what you can do is we can plug it back here in the main equation. Okay. In the main equation to get the area. And from that, we can also calculate W. But that would be too much time consuming. As we already have W here, we know how the substituted value of W works. We can just plug in the value of L here. So let's do that. That is actually our L for the vertex. Okay. And W is, let me recheck it, 1250 minus L. So 1250 minus L. Okay. And just plug it back here. 1250 minus 625 is 625. Okay. Now, there is a +1 question for you guys. Oh, I forgot to mention. Is there anyone who actually got a +1 for the first quiz and didn't make it 100% there? Because I can actually add +1 to your quiz score. Is there anyone? I guess Pearson was one of them. Who was the other two? Barbara, I guess. I remember 3 of you, right? If I don't make a mistake. So you can send me private emails, or you can even write in the chat section privately. If you haven't got 100%, and if you have a +1 for the quiz, I'll add that for you. Okay. Okay. So that's actually vaguely discussed for our main problem, because for our main problem, this is actually A. This was wrong. I'm sorry. I got carried away again. Because A, if you remember, or rather the way we define Y, is the functional value of X. Okay. Okay, I can see one message. Yeah, okay, I'll add +1 for you. Okay. Okay, okay, cool. Right. Got you. So if it's L, it's the functional value of that is actually A. Okay, so this should be our actual graph in terms of our problem, and we want to know what's the maximum value of A. That means what's the maximum area we'll get if we have a rectangle of length 625 and width 625. Okay, what we can do, you can always plug in f of 625 in this function, which is 1250L minus L squared. We can do that, or we can use our geometric intuition. Either way, you will get the same result. Okay. Okay, so you didn't get 100% on the quiz, I understand, but did you get a +1 from me by answering, a quick question? I don't remember giving you a +1, but that could be my mistake. Okay, yeah, I understand. No, it's okay. You'll have plenty of time. Right now, I'm going to ask another +1 question for tomorrow's quiz. So you can actually, what does it say in the parentheses? Where? Do you mean here? Oh, that's 625, yeah. I apologize for my bad handwriting. Let me rewrite it for you. 625. And I'm just trying to get the functional value, okay? So either way, you will get this result, 390, 625. If you just plug in the value, you'll get this result, okay? Either way, you'll get the same result, no worries. That's the geometric one, that's the algebraic one. Anyway, so here is a quick question for tomorrow's quiz. You'll get a +1 again. If you don't get 100% on tomorrow's quiz, you'll get a +1, which will be added to your score. So the question is, just by eyeballing the dimensions of the rectangle, how can you define this rectangle precisely? How can you call it? Good, I've got the right answer already. It's a square, okay? You get a +1 for it. So as you can see, the dimensions are equal. So your intuition should say that, hold on, if I have the same dimension, this rectangle has a specific name, which is a square. Yeah. Oops, I think I should write it again. Yeah. So yeah, good one. You'll get a +1 if you don't get 100%. And once again, you'll get, I think you'll get plenty of opportunities like this. So don't get disheartened if you didn't get it right this time. Okay, so that's problem 2 for us. Before we go for problem 3, any question from this? Anything, even if it looks or sounds stupid, don't hesitate to ask that. Okay, I'm more than happy to answer it. Any question from this particular problem? Looks like no question. So just give me a second so that I can actually stop recording now.